everyone, in this video, I'll walk you through a Matlab project that implements 6 different numerical methods to find roots of a function. We'll see how to run the code using the main.m, what each method does and how it finds the root. So, let's go. Main.m serve as the control driver for testing or running methods, typically includes user interaction, method selection, and calls to root finder functions, as you can see in this code. So now let's proceed to bisection method. Bisection method, a bracketing method that repeatedly halves the interval where a root lies. How it works: xl and xu with opposite signs compute midpoint. Xm is equals to xl plus xu divided by 2. Replace the endpoint whose function has the same sign as f of xm. Repeat until convergence. So now let's try to run this using this method. In bisection method, you need to input the size step, tolerance, and max iteration. As you can see in the given interval 0.5 and 3.5, the root is 1.7500. So now let's proceed to incremental methods. Incremental method searches the interval with a fixed step size to find subintervals where f of x changes sign, indicating a root. How it works: divides a and b into small steps. If f of xi times f of xi plus 1 is lesser than 0, a root lies between xi and xi plus 1. So let's try to run this using this method. So as you can see, the root of the given interval 0.5 and 3.5 is 0.5675, as you can see in this graph. Now let's proceed to postposition method. Postposition method, or the regular falsi method, similar to bisection but use a second line to estimate the root. And how it works: given bracketing interval xl and xu, compute the root approximation as the intersection of the second line xl, f of xl, and xu, f of xu with the x-axis. So now, let's try to run this code using this method. Now, as you can see, here's the root with the given interval 0.5 and 3.5 using the false position method. Now let's proceed to Newton-Raphson method. Newton-Raphson method, an open method that uses the function's derivative to find roots. How it works: starting from an initial guess xo and iterate using xn plus 1 is equals to xn minus f of xn over f of prime xn. Now let's try to run this using this method. Now, as you can see, the roots between the interval 0.5 and 3.5 using the Newton-Raphson method is 0.56714. Now let's proceed to second method. Now let's try to run the second method. Now from the given interval 0.5 and 3.5, the roots is 0.567143. Using the second method. Now let's proceed lastly to graphical method. Graphical method, visual finding by plotting the function. How it works, f of x over the interval, roots correspond to x-axis intersection. So now let's try to run this using the graphical method. So now, from the given interval, negative 0.5 and 3.5, the root is 0.5671. And that's all for this MATLAB project. Thank you.